Hey guys, so for all of these problems, or most of them I guess, there are multiple ways to do them, like multiple strategies you can use to integrate them. I'm just going to show you what I did, which I think is probably, on all of them, it should be pretty straightforward. Okay, here's problem number 1, 1 over secant t tangent t. So what I did, whenever I see something with like secant or tangent or cosecant or anything, and I don't immediately see something I can do easily, I just break it down to sines and cosines. So we know that secant is 1 over cosine t, and tangent is sine t over cosine t. So this whole integral will become integral of cosine squared t over sine t dt, and I just converted this to 1 minus sine squared t over sine t dt, and you can split this up easily. You get 1 over sine t minus sine t dt. Okay, then you can, that is equal to, well, this is the same as cosecant, so I guess I'll rewrite that. Okay, cosecant t minus sine t dt. So we know that integral of sine t is going to be negative cosine, so this will become positive cosine because the negatives cancel out. So we end up with cosine t, and then the integral of cosecant is something you should know off the top of your head. It's one of the weird natural log ones. It is negative natural log of the absolute value of cosecant t plus cotangent t. Then you add in your plus c, and that's the answer. Okay, so here's where I have a tip on speed. So you obviously see you could do the u sub u equals 5x, but I wouldn't do that on its own step because that's just going to add like 20 or 30 seconds, if not more. So I would just go straight to looking for trig things you can do. So when you have one tangent and a bunch of secants, then it's definitely going to be something like, well, this is the same as secant to the 5th of 5x times secant 5x tangent 5x. And we like this because secant tangent is a derivative of secant. So now we can do one u sub for secant of 5x. Let u equal secant of 5x. So du is going to be equal to 5 times secant 5x tangent 5x. So then we get is equal to, we have a 1/5 from here, 1/5 integral of u to the 5th, and then these cancel out, then du. And then that's easy to integrate. You get u to the 6th over 30 plus c, which is secant to the 6th of 5x over 30 plus c. Okay, this one's very straightforward. Since we just have sine and cosine, and when you have a product of powers of the two, you want to look for the one that's the odd power, because when you do your u sub, you'll only cancel out one sine or one cosine. And so our odd power here is sine, so we want to have everything in terms of cosine except for one sine. So we write sine x, there's our one sine, 1 minus cosine squared x, and there's our other sine squared, so this adds up. This is the same as sine cubed. Then we have our cosine to the 4th x dx. Now we can let u equal cosine x, du equals negative sine x dx. So we end up with a negative out front, equals integral of, this just turns into u to the 4th minus u to the 6th du. And then that's easy to integrate. We can just say that is u to the 7th over 7 minus u to the 5th over 5. And notice I just went ahead and distributed this negative and swapped it around. And plus c. So that's the same as cosine to the 7th x over 7 minus cosine to the 5th x over 5 plus c. There you go. Okay, so here, this is definitely going to be a partial fraction 1. So we can pull the 5 out. And then this pretty obviously factors into x plus 4, x minus 1 over 1 dx. So that will be equal to 5 times the integral of a over x plus 4 plus b over x minus 1 dx. So now I can come over here and say that a times x minus 1 plus b x plus 4 is equal to 1. So that means that a plus, or I'll write this all the way up. So x, a plus b plus negative a plus 4b equals 1. So a plus b equals 0 and 4b minus a equals 1. And this just means a is equal to negative b. So this turns into 5b equals 1 by substituting. So b equals 1/5. So a equals negative 1/5. Okay. And notice when we plug the 1/5 in, it'll just cancel with this 5. So we'll just end up with, get rid of this 5, we'll have negative 1 here and positive 1 here. So I'll go ahead and write it up here. Negative 1 over x plus 4 plus 1 over x minus 1 dx. That's equal to negative natural log x plus 4 plus natural log x minus 1 dx plus c. And you can also write that as natural log of x minus 1 over x plus 4 plus c. That's how I write it, just because I like to be clean, but that is not important at all. You don't have to write it like that. Okay, this one, you can do long division, but that might be a little bit extra. The easy thing to do here is, since we have this numerator, we can break it up. And notice we have x squared plus x is the same as x times the quantity of x squared plus 1. So if we break it up like this, x cubed plus x over x squared plus 1 over x squared plus 1 dx, this just becomes x. So we have the integral of x plus 1 over x squared plus 1 dx. That becomes x squared over 2 plus arctan x plus c. So that one's not too bad. Okay, so the first thing here is to not write it like this. We need to make a limit. Limit as a approaches infinity of this integral. Because this is not a physics class, we don't plug in infinity, that's a 0. 2x squared over 1 plus x cubed dx. So now since we have x cubed down here and x squared up here, we can just do u sub. Let's u equal 1 plus x cubed, so du equals 3x squared dx. So notice this also changes our bounds. So this will be, I don't know why my markers are all bad. It does not change the infinite bound, like infinity cubed plus 1 is still infinity, so I'm just not going to touch that. But it does change the lower bound because 0 cubed plus 1 is 1. So we end up with the integral from 1 up to a. And then we have 2/3 out front. There's a 2 from here and a 1/3 from here. And then the x squares will cancel out, so we just have 1 over u du. So then we get limit. Need that limit, boys. Limit a approaches infinity of 2/3 natural log of u from 1 to a. Nice. So this will end up being natural log, or 2/3. Nope, this one. Yep. Natural log of n. No, not n, a. Okay. Minus natural log of 1 is 0, so it's actually just this. But that is divergent, so there's no answer. It's just diverges. Okay, so just like on the last problem, we want to write this as a limit because we're not barbarians. So limit a approaches infinity of the integral from 1 to a of x e to the negative 4x dx. So we definitely want to do this by parts. So I will write this out front. A approaches infinity, and then we'll just have a big bracket, and every a will depend on that. That is an ugly a. So we do not want to integrate the x squared because then we'll just keep getting larger power values. Yeah. We want to integrate the e because that will not really change. We'll just get a constant out. So if we integrate the e to the negative 4x, then we can just get e to the negative 4x over negative 4. And we still have the x. So we end up with x e to the negative 4x over negative 4 from 1 to a. And then we subtract integral from 1 to a of this, but we differentiate the x. So we just have e to the negative 4x over negative 4 dx. Okay? So, what do we get? We get still the limit. A approaches infinity of negative x e to the negative 4x over 4 from 1 to a. And then this is easy enough to integrate because we already integrated this. We just pull out a constant. We get minus, notice we have a negative here, and another negative when we integrate this. So it ends up being, the whole thing is negative. Minus e to the negative 4x over 16. That also goes from 1 to a. So now if we want to actually evaluate this, we can plug in all the a terms and get one term that way. So we end up with negative a e to the negative 4a over 4 minus e to the negative 4a over 16. So that's the a term. Then we can subtract, plugging in 1 everywhere. So we get negative e to the negative 4th over 4 minus e to the negative 4th over 16. And this is actually where it gets tricky, trying to manage all your terms and evaluate them correctly. So it's important to keep this organized because it's easier to lose yourself. So both of these will end up being 0. This one, because obviously e to the negative infinity will be 0. But this limit, you do not have to do L'Hopital's rule because the rule is that exponential growth is always grows faster than just like anything else. So this is gonna get closer to 0 faster, and this is gonna approach infinity. So this is gonna tend towards 0. And I mean, you can use L'Hopital's rule if you want, but it's pretty obvious. So that turns to 0, that turns to 0. So the answer turns out to just be this, which is e to the negative 4th, 1/4 plus 1/16, which is 5e to the negative 4th over 16. Alright, this is just a basic integration by parts problem. So we want to imagine there's a 1 here, integrate that to get x. So we're going to end up x arctan x minus, now we can differentiate the arctan. We get x over x squared plus 1 dx. So this is pretty easy to integrate. We can just do a u sub. Let u equal x squared plus 1, du equals 2x. So we end up with x arctan x minus, then we get a 1/2 pulled out because of the du. 1/2 integral of 1 over u du, which is x arctan x minus 1/2 natural log u plus c. That should be a red u just because it looks cooler. So our final answer is plugging x squared plus 1 back in, so we get x arctan x minus 1/2 natural log x squared plus 1 plus c. Okay, so if we look at this limit, we're going to have the type 0 over 0 if you're just to plug 6 in. And so we use L'Hopital's rule. And this also means that we'll have a removable discontinuity or a hole in the graph at x equals 6. So that's the answer to 9b. But 9a, we just do L'Hopital's rule and we differentiate the top and the bottom. So this will be equal to the limit as x approaches 6 of the derivative of the top is 1 over 2 root x plus 10. Derivative of the bottom is just 1. So this would be 1 over 2 root 6 plus 10, and this is the same as 4, so we get 1/8. And that's the answer. Okay, so for this limit, we want to do the same thing and see what type it is. So if you just plug in sine of 0 is 0, tangent of 0 is 0, so we would have a type 0 over 0. So again, 10b will be a removable discontinuity or a hole. So again, we obviously can't plug it in, so we have to use L'Hopital's rule. Equals limit x approaches 0, and the top becomes a cosine ax. The bottom becomes b secant squared bx. And you can plug in 0 to these because cosine 0 over a b secant squared 0. And cosine of 0 is 1, and secant squared 0 is 1 over 1 squared, which is 1. So the answer is a over b. So for this limit, again, just use L'Hopital's rule. So is equal to the limit of x approaches 0. Derivative of the numerator is going to be a e to the ax plus a e to the negative ax over b. So then we can just plug that in. E to the 0 and e to the negative 0 are both going to be 1, so we get a plus a over b equals 2a over b. Okay, this question is a little bit trickier because you have to do a u sub inside of a limit. So if we just let u equal 1 over theta, then that means limit as theta approaches infinity is equivalent to the limit as u approaches 0 from the positive end. So this also means that theta is equal to 1 over u. So we can rewrite this as u approaches 0 from the positive end of sine u over u. And at this point, if you don't recognize this limit, then it's kind of sad. But I mean, you can just do L'Hopital's rule again and see this is equal to 1. So yeah. Okay, so here is the kicker. So at x equals 1, we have an asymptote. So we need to split this up into two integrals and use limits. So integral from got the limit equals limit as we'll say a approaches 1 from the negative side of 0 to a of 1 over cube root of x minus 1 dx plus limit as b approaches 1 from the positive side, integral of b to 2 is 1 over cube root of x minus 1 dx. Now, actually doing this integral is pretty basic, because it's just power rule. So you'll end up with limit as a approaches 1 from the negative side. This will be, what is it? 2/3, right? What I put? Oh yeah. 3/2 x minus 1 to the 2/3 from 0 to a plus limit as b approaches 1 from the positive side of the same thing, 3/2 x minus 1 to the 2/3 from b to 2. So, as we see, these limits are clearly defined because you can just plug in 1 and get 0 here. So this will end up being, when you plug in a, you get 1 minus 1, which is just 0, and that's perfectly defined with this power, or this exponent. So you just get 0. Then you subtract plugging in 0, which is 3/2 negative 1 to the 2/3. Then you add. Now you plug in 2 here, 3/2, that becomes 1 to the 2/3 minus, and again you can just plug in 1 and get 0. So this becomes just 2/3, or no, 3/2, and this also becomes 3/2. Did I do this wrong? Did I? I'm so confused. Oh, because this becomes negative 3/2. My bad. So negative 3/2 plus 3/2 equals 0. Yep, because there's a negative here, so this whole thing becomes negative 3/2, and this becomes 3/2, and they cancel. Okay, so now this was the fun problem. So this you definitely want to do by parts, because you can tinker with trig identities, but you never get to anything. So parts are secant and secant squared. Obviously we want to integrate secant squared, so we end up with secant x, which is our secant to the first, times tangent x, because integral secant squared is tangent. Subtract, then we can differentiate the secant. We end up with tan squared x secant x dx. Now we can use our trig integral and rewrite this as secant x tan x minus integral of this is secant squared x minus 1 secant x dx. So now if we split these up in our head, this becomes secant cubed x minus secant x. So So we can integrate the secant part because we know how to do that, or at least you should. It's one of the log ones you should memorize or have memorized. Secant x tangent x, and the negatives cancel out, plus natural log of secant x plus tangent x minus integral of secant cubed x dx. Remember, this is all equal to the integral of secant cubed x dx. So we can bring this over there. So we can just erase that and add a 2 over here. But then we can erase that, put all that over 2. So that is our answer. Bonus is pretty troll. Mr. Mayo's being a little funny here. So you just do the very simple u sub. Let u equal e to the x. So du equals e to the x dx. So we end up with the integral. E to the x cancel out from the dx. 1 over u squared plus 3u minus 4 du. And if you just look back at problem number 4, we had this exact same integral. And we know that that is equal to the natural log of u minus 1 over u plus 4 plus c, and there's a 1/5 here. So if you got 4, or you can just go look back at that question on this video, then you see it's this. So you just plug the e to the x back in, so we end up with 1/5 times natural log e to the x minus 1 over e to the x plus 4 plus c. So the bonus was really, could you see this u sub? Hopefully you did, because that was 3 points, even though it was only 5. How many points did he give? Yeah, I think he gave 5 points. Wrong. Cool. There you go.